All right, lesson 16, analyzing rational functions. All right, so we've done things like this in 20-1. So if we start off with a function like this rational function, first thing we're going to want to do is factor the top. So we'd say f of x is equal to x, whoops, that was weird, x minus 3, x minus 2, all over x minus 3. All right, so now what's going to happen here is that you can see that x minus 3 on the top is going to cancel with x minus 3 on the bottom. So this function would actually simplify to just x minus 2, right? That's what it was simplified to. But we always have to look at the original function to figure out what the permissible values are, right? Because this was my original function. So if I look down at the bottom, you're not allowed to divide by 3, right? Because if that was 3, that would make the bottom 0. So we have a non-permissible value of x is not allowed to be equal to 3. But if I look at this one, right, at the final function, 3 is fine, right? Because that'd just be 3 minus 2, that'd be 1. So you would think by looking at it that 3 is fine, but you always have to look at the original. So 3 is still a non-permissible value. But you can see that I'm no longer dividing by anything, right? Like the new function, I don't even have anything in the denominator. So what this becomes is actually just it's called a point of discontinuity. So this would be, so a point of discontinuity would be at the point f of x, or sorry, so if we had f of x is equal to x minus 2, and we'd say, okay, well, at the point of 3, right where we said we're not allowed to do it, so f of 3, if you put that in, that's equal to 1. So we have at the point 3 comma 1, this is a point of discontinuity, and I often just write it as POD or pod. So point of discontinuity. Okay, so the way that this will show up on your graph though, right? So I'm now dealing with, so f of x is equal to x minus 2. I'm now just dealing with a linear function, right? That's just a line. So that would cross through -2. It has a slope of 1 over 1. So that thing would just be like, a line going through there, right? But, and this is the way we draw it, at that point of discontinuity, so when x is equal to 3, you'd make an open circle right there. So that's where it doesn't touch, right? So this is our graph, x minus 2, but the point 3 comma 1 is not on the graph. Sorry, I shouldn't fill that in. It would be an open hole. So like that. Okay, so that's the idea. So now moving on to another one here. So the other part of this, we did this in the last lesson too, right? Was if there wasn't a point of discontinuity. So if I had, let's say, well, we'll do some examples, but we're going to have an asymptote, right? You'd have a vertical asymptote if you still had something left in the bottom, but I'll show you that here in a second. So on this one, it says compare the behavior of these two functions near any non-permissible values. So what we're going to want to do on both of them, I think, first, let's do the first one. So we'll say f of x is equal to, I'll just write that again. So x squared minus 2x over 4 minus 2x. The first thing I want to do is I want to factor anything out that I can, right? So let's rewrite this as, I'm going to factor out an x. So we got x, and then we got x minus 2 over, and then I'm going to factor a 2 out of the bottom. So we'd have 2. And then what's left here is that you'd have 2 minus x. And now we've run into something where, well, can I cancel that? Like I've got x minus 2 and I've got 2 minus x, but that's actually not the same thing, is it? Right? Like x minus 2 isn't the same thing as 2 minus x. That's like 3 minus 2 and 2 minus 3. Like those don't give you the same numbers. Those aren't the same. But here's what we can do. We can do a little trick here. If I'm just looking at, and here, I'll just write it. You don't have to write this down, but I'm going to write this just down here for a second. X minus 2. If I'm just focusing on this part of it. Well, just for a second here, let's just factor a negative out of this. So I'm going to actually just factor out -1. And then if I think what's left here, right, because I'd have 1 and then divided by -1, this would now be negative x. And then -2 divided by the -1 I took out, that'd be +2. And now if I just rearrange that a little bit, that's the same thing as -1 times, and just swap those two, 2 minus x. Okay, well, 2 minus x, right? That is that. So we were able to turn them into the same thing by just doing that little trick of factoring out a negative. So we'll do that up here on this one. So I'm going to say, all right, so is equal to, and then that x, if you like, I just want you to be able to see this, that this would be now like times, actually it's the best way to do this, times like -1 and then 2 minus x, right? Just factoring that negative out of there. Over, and then we've got 2 times 2 minus x. So now those guys can cancel, right? And then just cleaning that up, that would all end up being the same thing as just -x over 2. Okay, you don't have to write that all out the way I did. I was just trying to show you the way that, yeah, just so you can see it more clearly. Okay, so now what's going on here? So we have a point of discontinuity on this one. We've got a pod at x is equal to, and then it would be a point of discontinuity at 2, right? Because if x was 2, then you'd be dividing by 0, right? You can't have that. So you'd have a point of discontinuity at 2. You could add, yes, so then that point itself would be at f of 2, right? If I just put in, 2 into there. So f of 2 would be -2 over 2. So that'd be equal to 1. So the point itself would be at the point 2, 1, right? That would be my point of discontinuity. POD. All right, next one. So now g of x would be, okay, so looking at the top there, I'll just factor it right now. So we'd have x times x plus 2 over, and then I'll factor the bottom as 2 times 2 minus x. So now I could try, I could try to factor out the negative out of the top, but if I factor a negative at the top, that's actually going to be like -x minus 2. That's not going to be the same either way. So I can't cancel anything now. That's just as far as I can go. So in this case, we're not going to have a point of discontinuity, right? Because it's still going to be there, right? We're still, like this just is the equation. We're going to have a vertical asymptote, so a VA at x is equal to 2. And then if I try to, this one will be a little different. If I try to put in 2, right, like g of 2 into this equation, so just put 2, like an x or a 2 everywhere that there's an x, I'm actually going to get an error, which makes sense because it's going to make me try to divide by 0. So there is no actual point for a vertical asymptote because it's a vertical asymptote, right? That's going to be like, the dotted line where it was like approaching that, like it never does get to that point. Okay. All right. So yeah, that's pretty much it. I think we kind of explained the differences there enough. Hopefully you guys, that makes sense to you guys. Let's move on to the next one here. So now it says match the equation of each rational function with the most appropriate graph. Give reasons for the choice. All right. So looking at these graphs, I've got some vertical asymptotes. I've got a point of discontinuity right there. And then this one's kind of funny. I don't have anything, right? So let's just kind of see what we're dealing with up here. Let's actually factor each of these. So function A. So A of x, I'm going to factor out an x. And I've got x plus 2. And on the bottom, that's a difference of squares. So that would be x plus 2 and x minus 2. And then, okay, well, that means that I can cancel the x plus 2 and the x plus 2, right? Those cancel with each other. So looking at this, I've got a of x is equal to x over x minus 2. So I know a few things about this now, right? What this means, right? From this part of it, then there would be a vertical asymptote, right? A VA at 2, at x is equal to 2. And I also know that there would be a pod at the one that canceled out, right? That's what gives you a point of discontinuity, was the one that canceled. So there's going to be a pod at x is equal to -2. All right, so let's just look down here and see if there's any of those things. Well, yeah, graph 2, right? Graph 2 has that. You've got a point of discontinuity at -2, and you've got a vertical asymptote at 2. So this would be A, right? This would be A of x would be this graph. That's the only possible one, right? Okay, so let's keep going with this. So now this one, I can't actually cancel anything, right? There's no, like, I could factor a 2 out of there if I like, but like in the top, but there's nothing in the, that I, like, this isn't a difference of squares because we're adding, like, that's really nothing there. And if you kind of look at closer at this, there's actually no number I could put into this to make me get 0, right? Because if I put in, let's say, -1, well, that'd be -1 squared. That'd be +1. So that'd be 1 plus 1. Now the bottom's 2. So actually, there is no point in this where I'm ever going to be dividing by 0. So there is no POD, right? There's no POD. Or I should say no pod, and there's no vertical asymptote. And then these ones do some funny things, right? You won't be required to explain more about this graph, right? You might have to figure out where your x-intercepts were and where your y-intercepts are, but yeah, we're going to go through an example of how to do that below anyway. So anyway, the only possible one for that one is this one. So this will be B of x would be that graph, right? Okay, so let's just double check to make sure the next one makes sense, okay? So looking at the last one, let's factor this. So we've got C of x is equal to 2x over, and then we have a difference of squares. So we've got x plus 2, and we've got x minus 2. Okay, nothing cancels again, right? So these are just areas where I need to figure out my vertical asymptotes. So on this one, I have a vertical asymptote at, well, not equals, we'll say at, x is equal to -2, and x is equal to +2. So I'll write it as plus or minus 2. We'll say we have a vertical asymptote. So then looking over here, yep, that makes sense, right? We've got a vertical asymptote. Now, all of these squiggles and everything else going on the side here, they can be a little bit tough to predict, right? Don't worry too much about that. We're just going to, for the most part, figure out our vertical asymptotes and then go from there. It's kind of hard to tell, like, the shape of the graph and everything else, especially when you get like 3 of those lines. Like, it does weird things. Okay, so anyway, so that would be C of x. All right, so that would typically be it. But I think especially for your guys' assignment, I have a few questions there where I ask you to look at a graph, like one of these, and then tell me what the equation was, like work backwards. So I actually took one of those pictures. Oh, I should be on here. Uh-oh, where is it? Oh, I think I'm just glitching here. Yep, come on. Okay, we're back at it. All right, so now, here's the question. I've actually taken a snip out of your assignment, right? This would be like really similar to the one that you're going to have here, where it says write an equation for the function graph below. This is about as like tough as they get, I think. So what do we know? Well, we can see from the graph that we have vertical asymptotes at x minus 3 and x plus 3. So I think a good way to start on these ones is I'm going to say, okay, well, f of x, I'll write it up here. F of x is going to be equal to, and then if I have asymptotes at 3 and -3, then I know my bottom is going to be this, x minus 3 and x plus 3. Right? So that will be the case, right? Now I got to figure out the top. So now on the top, we've got a little bit, like, if we look up here, right, at these other ones we were doing, like this one, right? It was, to begin with, it had like an extra x on the top, right? And, a couple things canceled. This one, right? I've got my x-intercepts, I've got my vertical asymptotes, but I'm not sure if there's like, if this would just be like a 1 up top, or maybe it's like an x up top. I know that it's not going to be an x squared term up top, because then what that would do is that would make it so that I've got an x squared on the top and an x squared on the bottom. And if you remember, if we, from the last one, if I had like 3x squared over x squared and we graph that one, do you remember how that would end up having a horizontal asymptote at 3? We just took the numbers out front. And I don't have anything, like I don't have a horizontal asymptote on this one, right? It's not approaching anything there. Well, I guess it is. It actually would be approaching 0, it looks like. So, you know, anyway, we should be pretty good to go there. But the other way that we can figure out what's up top there is this right here. It crosses through the point 1 at the x-intercept. And why that's important is because if you think about up here, right? If I said x minus 1 on the top here, that has to be the case because let's say at this point x minus 1 up top, right? If I threw the point 1 in for x, okay, well then what that would do, that would make this 1 minus 1. That would make the entire top equal to 0. And then actually, I don't even really care what's on the bottom because 0 divided by anything is 0, right? So that would make my y 0, right? That would be like, does that make sense? Are you guys kind of following along with that one? So the top, the numerator is kind of telling me where my x-intercepts are. So I can see that it crosses through there. So I know that this has to be the case, right? That I've got x minus 1. So I've got it set up pretty well. And you'll probably be like, okay, you'll punch it all in and you'll think that's your answer. But that's not quite right. And here's why it's not quite right is because these graphs, just like what we did in like physics in the math 20-1, I don't know if you remember, we did like, you know, parabolas. And we did something similar where you had your x-intercepts. But do you remember how we always had to solve for that a value out front, right? Because there's like a stretch factor, right? There's a stretch factor that could be applied to this one that we don't know what that number is. So we actually have to figure out what the stretch factor is. It could be 1, right? It could be just look like this, but it might not be. It might be 2 or 3 or anything. So the way we can find that now is I could solve for x if I just knew what numbers to throw in for x and in for y. So what we need to do here, we have to figure out any other point on the graph. So I'm going to choose this one because it passes through the point 0, -2 nicely. So here, I'll write that down. It passes through the point 0, -2. Well, there's my x and there's my y, right? So I can throw those points into this and then figure out what value I need to get out for a. So instead of f of x, which really is just y, right? I'm going to throw in -2. So -2 is equal to, and I'm looking for a, and then instead of an x, I'm going to throw a 0 in there because that was my x value, over, and then 0 minus 3, and then 0 plus 3. Simplifying that all up a little bit, that would be -2 is equal to, well, this would just be -1a when I actually went 0 minus 1 there, over, and then this will be -3 times 3 once you're done adding those. So that's just going to be -9. A little bit more algebra here. This would be -2 times -9 would be 18 is equal to -1a. And then just get rid of the negative. So in the end here, this would be -18 is equal to a. So your answer when you fill this in would be f of x is equal to -18 times x minus 1 over x minus 3, x plus 3. And it can be in different forms too, like when it goes into the program there. So it could be like this too. It could be -18 times x minus 1 over, and then maybe this is even written as x squared minus 9, right? If you expanded that all out, they should all give you the right answer either way, no matter how you put it in. So yeah, like I said, that's about as tough as they get. And you've got, I think, like 2 of those on that assignment. So yeah, other than that, you guys have these textbook questions, and that's it for that one.